Hey everybody, a student threw this one across my plate. Came and asked me, they were prepping for a math contest, and they said, hey, I have this problem here. Can you solve that equation for x? And so we worked our way through it. I thought it was a great problem, so I thought I'd throw it out to everybody. So take a peek at the problem on the screen in white. See if you can work your way through and solve for x, and then we'll pop through a solution to it. Okay, best of luck. Okay, so there's the equation that you see on the screen. For us to be able to work our way through it, there were a couple things that we had to consider. The fact that we had variables in both the base and the exponent. Yes, we could take a log of both sides and be able to work our way through to be able to bring that exponent down, but then we were going to end up with variables outside the log and inside the log, and that got ugly. So the problem-solving method that we went through was we dealt with a little bit of inspection. That is, rather than just going straight to algebra, we take a look at the problem and say, well, within that relationship, what must be true? And so you take a look and you have a to some exponent giving you 1. And I hope that we're good, that when we look at a power equal to 1, well, then there's a number of ways that that could happen. I think probably the easiest thing to consider is the base being equal to 1. That is, we should be pretty comfortable to say 1 to any exponent is going to give you 1. So what that gave us then was a case that we could examine. And so let's jump into that. So I'm going to leave that blue just up on the right for a moment, and possibly then the first cases that we need to examine is what if the base equals 1? So what would make the base equal to 1? And since the base of that power is x squared minus 7x plus 11, when does that expression have a value of 1? So that would have been our first case. When is the base equal to 1? Now I can get rid of that blue on the right side. What that ends up creating for us is a quadratic equation, and I'm going to assume if we're working through this problem, we're pretty comfortable on quadratic equations. So I'm going to go pretty quickly. I cannot put my x's together into one variable term, so I'm going to write it in standard form. And my first option is to look to factor. I see that it does factor into x minus 5 times x minus 2. And therefore, I get a value of 5 from the first factor or 2 from the second. Nice. I just came up with 2 x values. Those x values make the base 1, and 1 to any exponent gives me a value of 1. We just solve for 2 values. Okay, but there's other ways to make that power equal 1. And the next thing that we came up with was, well, we kind of jumped ship on the whole base idea, and the student threw out to me, but wait a second, we could also get our exponent to equal 0. So what I'm going to put on in green is what if the exponent equals 0? If I have a value to the exponent 0, then that can give me 1. And we had to have a quick little side note discussion on, yeah, as long as that base doesn't equal 0, because 0 to the exponent 0 doesn't equal 1. But if my exponent equals 0 and my base does not, then that gives me a power that's equal to 1. So we followed through that. Well, what if my exponent equals 0? So I set my exponent equal to a value of 0. And same thing, I can't put my x's together into one variable term, so I'm going to look to factor. 2 numbers are multiplied to give 42 and add to give negative 13, negative 6 and negative 7. And therefore, I get 2 solutions that way. Nice. And then we started to mull some stuff over, and I posed the question, okay, have we forgotten about anything? Well, first off, we had that discussion about, well, wait a second, what if the base equaled 0? And so we had a nice quick look to be able to say, we've already examined a little bit in that process. We examine something about the base, rather the base being 1. But we never look to see whether the base equals 0. So what we need to do is we need to take both of those green values and do a substitution back up into that base just to make sure that that doesn't give a base value of 0. So a quick substitution, if I sub in my x equals 6, then my base becomes 36 minus 42 plus 11. Now, you can go through and you can make your calculation. Like, I don't care if you ended up saying it was 5. But really the most important thing was that it does not equal 0. So we can accept 6 as a solution. Do the same check with your 7. Sub x equals 7 back into the base. So 7 squared minus my 7 times 7. Well, that makes my calculation even easier. It's just 11, or again, not 0, so I could accept those as well. Okay, we then thought that we hit a bit of a wall, and we said, okay, we've got our 4 values, we're good. But we didn't consider one other thing, and this would be the thing that I would make sure we do not forget about. In fact, some of you might have thought about that first or second. There is another way to make my power equal to 1. What if my base was -1? Then what exponent would you have to put on -1 to give you 1? And if you pattern that out a little bit, I'm hoping that you can come pretty quickly that b is even in that instance. As long as my exponent is an even number, then when I calculate -1 to that exponent, it's going to make it a positive outcome. And there's my positive 1. So we have another instance that maybe we didn't consider. I'm going to shrink that down a little bit. I'm going to get rid of everything I just wrote. And we're going to now examine, what if my base is -1? I need an even exponent. So let's make the base equal to -1. So x squared minus 7x plus 11 is going to equal -1. Same thing, I can't put my variables together into one term, so I write it in standard form. I'm going to look to factor that, and it factors pretty quickly, and therefore x equals 4 or 3. And we might pause there and go, hey, look, I found 2 other values. But we got to stop again. Because what we just did was follow the criteria, or meet the criteria of the first part. We met the criteria that the base equals -1 for those values. But we don't know yet, do those give an even exponent? So the same sort of thing that I had to do on my green, I'm going to now have to do again. I'm going to sub x equals 4 back into my exponent. I need to see, does an x value of 4 give my exponent an even value? So I make my substitution, and I get 4 squared minus 13 times 4. Now, you could go ahead and you could calculate that. I'm going to be really lazy here. I see I have an even number, and another even number, and another even number. And I've got a little bit of theory in my background that says, well, there's no way that I can collect even numbers and have them give me an odd. So without even calculating that red, I can come to the conclusion that that is going to give me an even value, and therefore I can accept 4 as a solution for x. So let's look and do the same thing with our 3. I'm going to now sub in x equals 3 up into my exponent. Well, my 3 squared is a 9 minus my 13 times 3 is 39 plus my 42. I can do a lot of the same thing again. That is, I have an odd number, subtract an odd number. That's going to give me an even. But maybe we just calculate it and we say 9 minus 39 is a negative 30. Add on your 42. There I end up getting a 12. Again, I do not care that it's 12. It gives me an even, and I know I am good. Okay, that got a little small on our screen, but I'm hoping that we can take a peek at that now and see that for an x value of 5, 2, 6, 7, 4, or 3, those satisfy that equation. And so therefore, my x values are those values. 2, 3, 4, 5, 6, or 7. There we go. Okay, I hope you like that solution. I hope it helps you through your problem solving and prep. Best of luck.